Friends, I want to tell you how you can download COVID-19 data from a site, and you can extract useful information and plot to see the data in the way you want with the help of Python packages. So here is the data is the source data.humdata.org/dataset, etc., etc. So if I click this, it will go to the site, and it will show you this site where you can see that the data is maintained by John Hopkins University, some uh, Center for Systems Science and Engineering, and you can see where data are. Earlier, these were the files. These are the files, all CSV files. You can see perhaps I can make it bigger for you. These are the CSV files. CSV files means they are comma separated values. Basically, they are what I can see is that they are Excel sheets, big Excel sheets. Basically, they are big data, and now the data is maintained in this place. You can click that, and this data has been shifted to GitHub. So you can see many sites where they maintain current data day by day basis. Here is one. You can go here, and you can check the data. You can download the data, and you can do whatever you want to do. So for that, you need is something. You need some packages from Python. Okay, let's see what we can do. Yes, uh, yes. To do a very preliminary kind of observation and extraction of data, etc. This is a very preliminary step for big data analysis. So what you can do is that you can import three packages: NumPy, Pandas, and Matplotlib. These are enough. NumPy is numerical Python. This will be used for making arrays if you want. Pandas is panel data. This deals with the structure of the data. That means data are coming in the tabular form with rows and columns, written different things on rows and columns. And so how you handle those structured data, and you can convert the data into your known form in terms of list or arrays, so that you can manipulate the data, and you can finally plot the data to see through Matplotlib package. Particularly, I use PyPlot. PyPlot is the module which will plot two-dimensional things. Okay, so here I have already from this site, from HumData site, I have already downloaded the useful files, three files beforehand in my computer. So I want to read those files. Okay, if you want to see how those looks, these are the files. One of the files is this time series. I can make it bigger for you. I can make it bigger for you too. If you can see, can you see? Okay. Uh, if you click this time series 2019 nconf confirm, there are three kinds of files: for confirm cases, for death cases, and for recovered cases. So that's how they maintain the data initially. So I downloaded the data there from, and suppose this file I want to open. Okay, this is an Excel sheet, and you see the structured form of the data. This is the structured form of the data. You can check that there are actually different columns. The first is this some province, then country, then latitude, longitude, and the data maintained data from this site. This 22 1, that means January 22 to onwards, and in this particular case, the data is maintained up to, if you go this way, this data is maintained up to 23rd March. So this is for demonstration. You can download the current data at the moment and you can check accordingly. Okay, so let us go back and we can see what we do. First you import numpy as np, then import pandas as pd short name, then import matplotlib.pyplot as plt. This is standard. Okay, so before I go, before I go to show you, I restart and clear all output. Then I will show you better. Okay, and this is what I'm doing is what I am doing here is on Anaconda. And this platform is Jupyter Notebook. You can do it on anywhere, but for big data analysis, this platform is very preferred. Okay, so basically I run this. So let me run again. This is taken probably. Yeah. Now next there is a function or method called read_CSV, which in PD, that means in pandas, there is a function called read_CSV, which reads the CSV file. What is the CSV file? I give the whole path name here. This is the entire path name, and this is the name of the file, time series 2019 nconf confirm.csv. So I read the Excel sheet file, that means the CSV file, and I read this file. What is the form of the file? We don't know still, but we rename it in a short name, data_conf. You can give any name. Similarly, for the recovered cases, another file, I rename it and with data_recov. For the file which counts the dates of this, so it's the nconf dates.csv. That file I read this and store it in the name data_date. So these are the three objects: data_conf, data_recov, data_date. Let me run this. Okay, it has taken. See here the number has come, so that means it has taken. So now let us check what is this data_conf or any other. These things are, what are those things? So if we type something, type is a function which will tell you what is any object in Python. So it's a very common thing. Whatever any object you get and you don't know what is it, you can check it by this. So if I run this, it will give me pandas.core.frame.dataframe. Basically, it is a data frame. Data frame is a particular kind of data structure in pandas. So basically, if you do not know pandas at the moment, so you have to understand what is data frame, basic idea of what is a data frame. So let me give you an example. For example, suppose your data is in this form. Your data is in the dictionary form. That means A is the key and the value is 10, 20, 30 in the form of a list. B is another key and its corresponding value is in the form of another list, 50, 60, 70. And I can also put one index equal to 1, 2, 3. That is another, let me make it bigger. That is another list. So if you now see pd.dataframe, so inside that, if you write data argument, if you write data comma index, so it will, what it will give, let me see what it will give. Okay, it will give you a structured form of data. That means it is giving you a table. So this is data frame. Your A and B, the two keys are on the two column names, and the indices 1, 2, 3, they are on the this row names, and the data 10, 20, 30, 10, 20, 30 corresponding to A, and 50, 60, 70 corresponding to B. So the kind of, these are the already known things, the dictionary, list, everything. So you combine them and you get a structured form of data, that is called data frame. Okay, now you want to see what is the, this is, so that means you are convinced that data underscore conf or the rest of the two, reconf or date, all are kind of data frame. So now you want to see what is this, what is in there in this data conf data frame, what are the entries are there. So since the files are very big, so you don't want to see the whole file, right? Instead you want to see the head some of the some of the entries from the beginning. So that is you call head. So if you write only head, it will show you I think the first 5 entries. So let me run it. Oh yeah, so it will show you the these things. So first is the indices 0, 1, 2, 3. These are serial numbers. Then province, there is no entry, so they are nan, no, not a number. Then you don't have to worry about these things. Then country or the region, Thailand, Japan, Singapore, Nepal, Malaysia, and so on. The way they have entered the data, it is up to them. Then for some reason they have entered latitude and longitude. So now the actual COVID data begins from here, 22/1, from January 22. So these, all the rest of the columns will be for the data. So if you want to see, say for example, say 50 instead of 5, you want to see the 50 entries. So you can run them and you can see the whole 50 entries. So you can inside this argument you can give anything. Okay, so that way you know where is the country in this. You can see this India belongs to the 15 number entry, but there is a better way to see it. Of course, you can actually, I'm coming to that point. Okay, so but before that what you can do is that you should convert the values. Say data underscore conf. You should convert this data frame into something which is manageable by you. That is, you want to convert this into a list or array or something. Suppose I want to convert this data into entire data in the form of a list, because then you have the machinery at your hand. You can slice the list, you can extract certain portion out of the list, you can know by indices where which stands where, etc., etc. So that way you can manage the list. So the mantra is data underscore confirm conf, that is the data frame, dot values dot to list. So that is a method. To list is a function. Under it is values under this. So data underscore confirm dot values dot to list. So I call it, say, L underscore confirm. So that means a L list, L confirm list. So confirm list, this is in the same way, this is recovery list. In the same way, it is the list for death. You could also write this way: data underscore confirm dot to underscore numpy. This is one method. To list function. So you could also use that. Anyway, so let me run this for you. Okay, this is taken. Now you want to see what is lconf. Obviously this is a list from this I can get, but if you want to see that you can run that and you can see that. Okay, so this is a list. It's a huge list because huge list means because it has taken everything. It has taken everything from the first to last. So basically it's a huge thing. Rather, Rather I may not bother you to see this. I can delete it. Okay, let me check. Oh yeah, let me grip this for you. Let me grip this for you. Yeah. Yes. Oh yeah. I just wanted to show you that this is a kind of list under a list. So it's a two-dimensional list, and it begins from nan. Serial number doesn't come. It's a nan, then the country name, then the latitude, longitude, and then the data entries. So it is for Thailand, and then you go on like this. Then the next entry is again nan, Singapore, and latitude, longitude, and the data this way. So this is a basically it becomes a two-dimensional list. So let me go here. Okay, now in the data conf is a data frame. Inside that, where India figures, if you want to see that. So if you write inside the square bracket, quote unquote country region, and then equal to quote unquote India, then it will tell you it is a kind of searching by index. So it will tell you where India is, and this is through data underscore confirm conf dot loc. That means it is trying to tell you the location of India in the data frame. Okay, so if you run that, it will show you this, right? So here is India, and the serial number is 15. So thus India's serial number is 15. You can have a different method to do that, but okay, I can tell you this. So this is one thing you can do. Okay, so this is India. So India's serial number is 15. Now I want to plot all the data, confirmed cases for India, recovery cases for India, and death cases for India up to that time. What is in the file, and the see L. So I use that lists L underscore confirm. I write 15. 15 is the India's case. So I rename it as confirm underscore India. Similarly, L recov 15 I rename is at recov India, then death India. So this is India's case. Similarly, from the data frame, by the same way, by the same searching, in place of India, if you write Italy or Spain, it will give you Italy's position, and then the I know the Italy's position is 16 in this data file, and these Spain's position is 18, and this UK's position is 403. So I wanted to compare these four data, for example. So confirm India, decov India, death India, confirm Italy, decov Italy, death Italy, and so on. Okay. So this is this, and see, and I want to know, this is the list. So in this list, I want to know what is the length of the list. That means what is the length of the list means this whole thing is a list. This is a complete list, and the entries are these, and all those. That means the total number of columns. So that I call it days. I call it the days, because of course in this column, in this list, these first four entries are not the actual days. Dates begin from here. So the apart from the first four elements, the rest are the days. So I just call it days. So confirm India, and I check what is the length of this. That means total length, and I create a list of days. So I call it, because while plotting, I can give the dates as 1, 2, 3, 4, 5, 6 like that, from 0 to 0, 1, 2, 3, 4, 5, 6. So I create a list out of this. So len of confirm India and then range of it. So I call it the days list. So this is the list. Okay. So I now run this. Okay. So I now run this. Okay. So it is run. Now I want to plot the figures. First I write plt.figure, figure size 10:8, that is something for decoration, and the plt.subplot. I want to plot 4 countries side by side. So it is 2 to 1 position. In subplot it is 2 to 2 position. It is 2 to 3 position, Spain, and then it is 2 to 4 positions. And the rest are the things that I want to plot plt.plot, but check here. So days, because the first 4 entries in days are something which we should not plot. These 4 entries, these first 4 entries. So I discard the 4 entries, and so I check it. This is slicing. So in the list, I take the data from 5th entry onwards. 5 colon blank. That means I go from 5 to the end. Similarly, for the confirm India list, I go from 5 to same number of has to be. I go from 5 to end, and I plot with this line and bullet. Okay, this is plt.plot. I write the text at certain position 4300 by checking the figure. I write India, size, and then X level, and so on. And the same I do for Italy, and then Spain, and then UK. Now I want to run this and see what comes. Okay, so yeah, what is this coming? Yeah, yes. Let me make it smaller for you. Let me make it smaller. Let me make it smaller. Okay, even smaller. Okay, so these are the 4 cases. So these are the what I have plotted. I have plotted the confirmed cases. So India confirmed cases up to that March 23, then Italy, and then Spain, UK, 4 countries. If you want to plot together, you can plot together. But remember, this is just a demonstration. I'm not doing any model out of it at the moment here. Okay. So now, if you want to plot the derivative of growth, so growth rate, you want to take the derivative. So you can use the NumPy machinery, and see you can use that. You can use that. Okay, you can use that. Okay, let me make it smaller. Make it smaller. It is hanged for some time. Please wait for some time and see. Yeah. Okay. So what I want to do is basically this. I want the same data, but I want to take the difference. Difference means this is. Let me make it bigger for you again. This is what I want to do. That means I take the confirmed cases, and of course I convert this as in NumPy array, because the list doesn't have all those methods on it. So np.diff means it takes successive differences. That means I want to check the rate of growth of confirmed cases, for example. So this confirm India 5 colon this so this data, this is the list. I convert it to NumPy array, and then I apply np.diff method over it. That means it gives you the list of differences of successive numbers. Okay, and so since y is the difference, so x value should be from 6 onwards, because 1 less. Okay, because there is a difference. So if you plot this x versus y, and the same way you do it for Italy, Spain, and UK. Okay, if you do that and you run this, let me see. You get all the 4 curves for the differences. Same curves but with differences. That means these curves are for growth rates basically. Now, if you want to check something more, suppose you want to see what is the percentage recovery case. Percentage recovery case means if you the recovery case and you divide it by the confirmed case. So this you want to see. Okay, so the ratio between but with NumPy it is easy to do ratio between this recovery India, and I take data from 12 onwards because the first for India the first 11 days there was no data, so I take it from 12, and so for India I'm checking it. So recover underscore India 12 colon, and I convert this as NumPy array. Otherwise, this is basically a list. Recover India, this is a list. So I convert this as NumPy array. Similarly, inside NumPy array, you write confirm India case. So this is the ratio, and then since the numbers are integers, see you can declare d type, means data type equal to float, to be on the safe side. But for Python 3 it is of no problem. If you are using Python 2, you must declare this d type equal to float, otherwise there will be integer by integer, and then you finally multiply by 100. So this you call f underscore recof underscore India. That means recovery, percentage of recovery for India. Then similarly you do percentage of recovery for Italy, then for percentage recovery, fraction of percentage recovery for Spain, percentage recovery for UK, and then you similarly do the same similar way percentage death for India, Italy, Spain and UK, and you do the same np.array death underscore India, this list, make it NumPy array, then divide it by this NumPy array with confirm cases, and same thing. Now I see if I run this, now I see what it gives. Okay, it is objecting something. That means because there is somewhere in some data there must be some division by 0. It has invalid value encountered something, but you can check that, but it won't be having problem. It will plot, no problem, because it is so clever. It will automatically disregard that point and it will plot. Okay, so let's see. Okay, yeah, it is becoming so slow. Let's see. Okay, let's see first. Okay, well, please wait for a moment. Let it come back. Okay, let it come back. So maybe because I have clicked so many times, so that it is revolting. Okay, but yeah, anyway, so this is how okay. So after that, okay, so the calculations has been done here. For example, if you want to see, for example, these are the India, Italy, Spain and UK. I checked this, for example, what is this fraction of recovery of Italy. If you want to check that, you can run that. What are the data there? If you do that, well, so this is the culprit. You can see this is the culprit, nan. So in the Italy data, so this was probably giving trouble. Maybe that is there in other list also, but doesn't matter at the moment. Now you go to plot these data, and you go to plot this data. So again you write plt.figure fig size equal to 10.8 and the subplot 221 222 etc, and you plot the data for the days. You discard the first 12 days data just for the sake of something, because for India probably there were no data for first 11 days or so, and so I did the same thing for all the countries. So days 12 colons this blank, then f death India plot, and then along with this I plot days with recovery India. So death and recovery I plot together. This is for India, this is for Italy, Spain and UK. Okay, now if I run this, yeah, it will show you this four plots together. So the blue is death and the orange is recovery. So you can analyze the two things. Of course, for India, it was all the data were at the preliminary stage, because Italy and other places, Spain, Europe, they were affected much before India. So you can see the rise of Italy. Italy was the worst case probably in Europe. So you can analyze, you can check the data, you can have a visual thing for this. Okay, now you can check separately the China case. Where China, because China is the special case in a sense, it began in China and lots of data are available. I do not know about the validity of the data, but that's not my point. My point is to whatever data is available, I want to plot them and see and can show you how we can deal with the data. That's it. So in the same way, in the location, if you the same way I found out where India belongs, I found out where China belongs. Okay, so if I run it now, for China, they maintain data for all the provinces. I counted, there are 50 provinces in China, they maintained. Worst case is Hubei, where the Wuhan city is there, and it begins from here and it maintains data in this particular site. For China, they maintained separate files for all the provinces. Okay, so let's go back, go to check. Let's go to check this again. It is hanging. It is revolting. Okay, let's see. It will come back. Please wait. Okay. Yeah. So you can see the province in the column of province. You see the names. Earlier the names were NAN, and the country, latitude, longitude, and all the data. Okay, here. Okay. So I want to plot all the data. So what I do is that since there are 50 provinces, I want to make a for loop here. Instead of individual plotting, I made the same thing in a for loop. So this is the figure declaration, and for I in range, I have seen that this begins from 154 to it goes, Tibet is say 202. So the range goes from 154 to 203 because it don't touch 203. Then the confirm China is L confirm, and the I means this index. Okay. So and in the same way what you did for the other countries, India and other countries, except because the data is very big here. Some data are very big here compared to other data which are very small. So the best way to see is in the log scale, semi-log scale. So for the y-axis you put in semi-log. So it's a semi-log y. So if you show it in semi-log, so plt.semilog y, and the days begins from 5 colon, and the confirm China 5 colon, and this, and then the particular I have in the text I have put the name of Wuhan in Hubei because I know which is the Hubei's curve, and in the title you write this, then level, then tick params. You can decorate all those things, and now you can run them. You can run it. You can run it, and you can see what is becomes, yeah, this is what you get. This is what you, even smaller, and this is what you get. So this is the China case, COVID-19 confirmed cases, and you can see this curve is complete out of all those provinces, because this was the epicenter of the pandemic. So this is Wuhan, and this is the curves. Now, if you want to see these, some curves are regular, falling almost parallel to others, and the other curves for the other provinces are something away from it. I don't know why. That is another matter. But if you want to discard all those this sum data and plot to see a better way, you can then discard the one loop will not do. You can discard some data, and you plot the same thing, and you plot the same thing, and you run this, and you see the clean data. That means the some of the provinces which follow the similar curves is parallel to Wuhan in this log scale. This is the confirmed cases. So same graph, this same graph, we've discarded the other some provinces. Okay. Now it is the case for percentage recovery case. Now the same way, if you want to see the percentage recovery cases, that means you want to check here. You want to check the recovery cases. Then you want to divide them by the confirmed cases. Then the confirmed cases. This is the recovery case. Let me go back. Let me go back here. Yeah, no. Okay. Let me go back. Where is gone? Okay, here it is. Recovery for China, 12 onward. I did not plot all the data from the beginning. 12 onwards I have plotted, and this 154 index is for Wuhan, for Hubei. So this is this thing, and you divided this R by C, that the same thing we did earlier, and multiplied by 100. So this will become the P4. P4 will be the percentage recovery case. And for the other things, some other provinces also, you do the same thing separately in different for loops, because you used different for loops because you had to discard in between some provinces data. So if you run this, you will get this nice looking sigmoidal curve. So one interesting thing is that it has to happen actually in our country also, because the percentage recovery is all the people will be recovered. The recovered cases will eventually, it has to go to close to 100, because death rate won't be that much. So anyway, it will all the curves, you can scale it appropriately. All the curves follow a sigmoidal curve, but the Hubei case is slower than them, because Hubei was the Wuhan or Hubei was the epicenter. So this is what you can get. Now you can do the analysis, you can do some modeling, and you can plot the data in very many different ways. You can check the what I plotted. You can check the death rate, percentage death rates, etc., and check what we have got. The same way, if you get, it is this is I plotted for China. Let me see why it is not coming. This was the percentage death rate for China. This is quite noisy. Quite clumsy. This is looking. This is precisely because some provinces took some kinds of measure, and their demography are different. Their management was completely something different, so they responded in a different way. So you can analyze them in your own way. I wanted to see the Japan case. So Japan is the number one. So I did the same way, and this was percentage recovery case and the percentage death recovery and death for uh, Japan. So this was early stage in India. I did it for India also. And so this is the story. So if you have got the data, the first thing is that you can you first have to download the data, number one, store it in some directory, then take the data, see the data is in which form, read the data through PD, the pandas machinery, pandas method, and they convert the data into either list or array, and then you can handle better. Then you plot. Okay, that's it.